Part 2 of Lesson 5, Solving Radicals Algebraically. So if we're going to solve radicals algebraically, we need to get rid of the square root. And so how do we do that? Well, the first step is to get the square root by itself. So right now, the square root's by itself. There's the square root, and then there's a constant on the other side. And so once we have that, our first step is to square both sides. Why? Because squaring and square roots are opposite of each other. They cancel each other out. So now we're left with x plus 1 equals 4 squared. 4 squared is 16. And then last, subtract 1 to both sides. We get x equals 15. Then our last job is to verify our solution. Sub it in and make sure left side equals right side. So square root of 15 plus 1 equals the square root of 16, which is 4, and 4 equals 4. Okay, so let's try another one. So this example, the square root's not all by itself. So the first thing we want to do is isolate the radical. So we subtracted 3 to both sides. So now the radical is by itself. So after the radical is by itself, we're going to square both sides. The square cancels the square root out. And so that's going to give me x minus 1 equals. Now here we have x minus 3 squared. Remember when we square a binomial, we have to expand it. X minus 3 times x minus 3. Now we're going to use distributive law. So distributive law, I have x minus 1 equals. So remember distributive law, first we want x times all of this and then minus 3 times all of this. So we're going to write that out as x times x minus 3 and then the negative 3 times x minus 3. So first the x distributes times all of this and then a negative 3 times all of that. Okay, so let's simplify this. X minus 1 equals x times x is x squared. X times negative 3 is minus 3x. The negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. Now we need to move everybody to the right side. Let's still simplify this side before we bring everything to one side. So we have x squared. Negative 3x minus 3x is minus 6x plus 9. So we're going to add 1 to both sides. So add 1 and minus x. We need to get one, whenever we have an x squared, we need one of the sides to equal 0. So I have 0 equals x squared. Negative 6x minus x gives us minus 7x, and 9 plus 1 is 10. So we have a quadratic, so we need to factor it. Now this is a simple trinomial because the number in front of x squared is 1, the coefficient's 1. So we want two numbers that multiply to the last, which is 10, and adds to negative 7. So if we make our factor tree, 1 times 10, 2 times 5, we want to multiply to a positive 10. So we need two negatives in order to add to a negative but multiply to positive. Negative 2 and negative 5. So we have 0 is equal to, so we're going to go straight to factored form, x minus 2 and x minus 5. So we're almost at the solution. So we have two solutions. So basically what we have is, if we have a product that equals to 0, then either x minus 2 equals 0 or x minus 5 equals 0. And so solving for x, add 2 to the other side, I get x equals 2 or x equals 5. So the question is, which one is it? Well, how do we know which one it is? We're going to verify. So we're going to sub both of these answers in and see which one's right. So we're going to do a check. So verifying the solution, the equation was, we always go use the original. 3 plus the square root of, so let's first do x equals 2. 2 minus 1 has to equal 2. So 3 plus Square root 2 minus 1 is 1, and square root of 1 is 1. 3 plus 2 is 4, not 2. So that is not true, and therefore x equals 2 is not a solution. So we'll try x equals 5. Sorry, this went longer. I'm going to move some of this up. Okay, so 3 plus the square root of x minus 1, our x, and the other one is 5 minus 1 has to equal to 5, our x. 3 plus square root of 5 minus 1, so 5 minus 1 is 4, square root of 4 is 2. 3 plus 2 is 5, so that is our solution. And that's why if we solve algebraically, we have to check our answer, because algebraically, there might be one solution that's false. So grabbing our graphing calculators, it says to check our answers with our graphing calculators. There we go. So when we solve these problems with our graphing calculator, the left side is y1, the right side is y2, and we're going to find the intersection point. So grabbing our calculator, go to y1. We might want to go zoom 6, go back to normal. So everything's back to normal. Okay, so we have to change our equation. So y1 is 3 plus the square root of x minus 1, and y2 is x. And sometimes our problems could have more than one answer. Okay, so let's look. Graph it. You have to be able to see your intersection point. So we're going to zoom out. Oh, there we can see it. So second, trace 5, enter, enter, enter. Okay, there's going to be a problem. So it says first curve. I actually have to make these points appear. So this is where you want to scroll and actually find the intersection point, and then we can push our enter 3 times, and we only need the x equals 5, and there's our solution. Okay, you do need to know how to solve a problem algebraically, not just graphically. So it's very important. So on a test, I could ask you, what is the answer? Now, notice how x minus 2 was not true. We rejected that. So any root that we reject, it has a special name, and the special name is extraneous. It's an extraneous root. Extraneous. Extraneous, like extraterrestrial or something. It's not from this world, right? It doesn't belong. So extraneous does not belong. It's the one that did not verify, work out to be true. So on the next page, it basically talks about, okay, what's extraneous? The extraneous solution, or the extraneous root, is the one that was false. The false solution is the extraneous solution. So complete the following to determine the extraneous root. So they started us to work for us. So they square both sides. Remember, the square and the square root cancel each other out. So we have x plus 2 equals x squared. Now when we have an x squared, we want everything to one side and the other side to be 0. So we're going to bring everything over with the x squared. So minus x over and a subtract 2 over. So now I have a simple trinomial. Remember, with a simple trinomial, we're going to factor it. We want two numbers, then multiply to the last, -2, and adds to the middle. So if you don't see a coefficient, that's a 1, a minus 1. So we're multiplying to -2. Whenever we multiply to a negative, we need one positive or one negative. So it's either -1, +2, or 1 and -2. Now it's the second one. It's 1 and -2 because we also have to add to -1. So now, because it's a simple trinomial, we can go straight to factored form. So x plus 1, x minus 2. Now we know this product equals 0. That means either x plus 1 equals 0 or x minus 2 equals 0. So solving for x here, I have x equals -1. If we subtract 1 to the other side, -1 minus 1 gives me x equals -1, or adding 2 to both sides, x equals 2. The only way to figure out which one's extraneous is to do a check. So we're going to do our verify. We always use the original equation, so we'll start with x equals -1. So negative 1 plus 2 has to equal negative 1. So negative 1 plus 2 is just 1, and the square root of 1 is 1, positive 1. And 1 does not equal negative 1, so that's false. Now it's possible to have more than one extraneous, so we have to check both of them. So we'll do the check now for x equals 2. Square root of 2 plus 2 has to equal 2. So square root of 4 has to equal 2, and square root of 4 is 2, so that is true. So our extraneous root is 1. X equals 1, or negative 1, thank you, sorry. X equals negative 1. The thing about extraneous roots too is you have to be able to solve it algebraically in order to find them. Graphical will not help you find the extraneous root. Okay, so turning over to the next page, we have one more page and then we are finished. It says isolate the radical. So these are the steps for solving. So let's solve them. Okay, solve the following radical equations. Verify all answers at the end. So first, the radical is isolated, so we're going to go straight to squaring both sides. So we have x plus 3 equals, because the square root and square cancel each other out, equals 49. Subtract 3 to both sides. And we have x equals 46. And so we just do our check. Square root of 46 plus 3 equals 7. So square root of 49 should equal 7. And it does. And so it's true. That is our solution. Try another one. Our first step is always to isolate the radical. Get the radical by itself. So we're going to subtract 7 to both sides. That gives me square root of 49 minus x equals x minus 7. Now what do we have to do to both sides? We square both sides to get rid of the radical. Okay, so that gives us 49 minus x equals. Now here we have a binomial times a binomial. So we have to expand that out. Now it is a perfect square, and so there are patterns, but it's kind of safer just to go the old-fashioned route, to write it all out. But we'll talk about the pattern in a second. So 49 minus x, we still have over here. On this side, we'll have x squared, so we're using distributive law here, distributing the x and the negative 7 in. So x times negative 7 is negative 7x. Negative 7 times x, negative 7x. And negative 7 times negative 7 is a positive 49. Now we need to get everybody to the same side, as well as collect like terms. So I'm first going to collect like terms here, because we have a negative 7x and a negative 7x. So x squared minus 14x plus 49. Now when we have a perfect square binomial and you're squaring it, to get it, we square the first term, x squared. To get the middle term, we multiply these two together and double them. So negative 7 times x doubled is negative 14x, and then square the last one is positive 49. So that's the shortcut. It's a little safer just to do all the work. I'll just give you another example. If I had 2x minus 3 squared, so squared the first term is 4x. Squaring the last one gives you, so plus 9, negative 3 times negative 3 will give you the last term. To get the middle, we multiply them two together and double it. 2x times negative 3 is negative 6. Doubled give you minus 12x. Add the little square there. Okay, so there is a pattern to figuring out, to expanding trinomials that are, or perfect squares, but it's safer just to use by the distribution law. Okay, so let's move everything to one side. I'm going to subtract 49 to both sides, and I'm going to add x to both sides. Okay, so these are gone. We have 0 is equal to x squared minus 13x, and the 49's cancel each other out. So this is not a trinomial, it's a binomial. So our first thing is there a GCF? And we can factor x out of both of them. Factor x out. And so there we go. So just continuing this up, we have a product that equals 0. So either x equals 0 or x minus 13 equals 0. So x equals 0 is already done for us. The other one, we need to add 13 to both sides. So x could be 13 or it could be 0. So let's do our check. So starting with 0, 49 minus 0 plus 7 has to equal 0. Square root of 49 is just 7 plus 7 has to equal 0, and they don't. 14 does not equal, so we put just a not equal all the way through. So that one, x equals 0, is extraneous. So now we try 13. So square root of 49 minus 13 plus 7 has to equal 13. 49 minus 13 gives us 36. Plus 7 has to equal 13. Square root of 36 is 6. Plus 7 equals 13. So that is true. So x is equal to 13 is the solution. Okay, one more example. So what if we had a cubic? A cubic. Now the nice thing about cubics is there are no restrictions. So we do verify, but there should only be one solution here. So what we're going to do is we still isolate the variable. So I start by adding 5 to both sides. So I have the cubic root of 2x minus 7 equals 5. Now how do we get rid of a cubic root? What will we do to both sides? We'll cube it. That cancels it. The cubic root out, so we're just left with 2x minus 7 equals 5 cubed is 125. And now we solve for x. Add 7. 2x equals 125 plus 7 is 132. And then we divide both sides by 2, which gives us 66. X equals 66. So we just do a verify. Cubic root of 2 times 66 minus 7, subtract 5 should equal 0. So we have 2 times 66 gives us 132. Take away 7, minus 5 should equal 0. So cubic root of 125 minus 5 should equal 0. Cubic root of 125 is 5, so 5 minus 5 does give us 0. So that's true, and so therefore our solution is x is equal to 66. And so this is the end of this lesson, and the rest of the homework is numbers 5 to 13.